Hi, everybody. Today I'm going to try and help you make the leap from point slope form of lines to the vertex form of parabolas. You're going to notice that the two equations are almost identical. We're going to use the idea of zero multiplication and that the fact that zero times anything is zero to help us. And that is a connection with solving quadratics by factoring, and we use the zeros to solve those. But here it is. Here's our first example. And you're going to notice that the two equations are identical except for one thing. This one on the top is to the first power, which makes this a line. This is a linear equation. The one on the bottom is to the second power. Now, hopefully you did your practice and understand how point slope form works. Point slope form says that in order to get a point on this line, we can do this in any way we want. We can choose any x value, we could choose any y value, and then we could fill it in. And a very common x value to choose is 0. The problem with choosing 0 for x in this case is that we're going to end up having to simplify, and we're going to end up solving for the y value. We're going to have to add the 3, take it to the first power, multiply it by 1, add the 1 to both sides. It's not that difficult. You get 4, but it's much easier to simply choose the x value that will make this 0. And the x value that makes this side 0 is -3. If I put a -3 here, this side, this entire right side is 0. In order to make this true, I need to make the left side 0. And in order to do that, I need a y equal to 1. That's where that point comes from and why I call this zeroing out my equation. Now I'm going to go to -3, 1, which happens to be right there. And I can count my slope over and over and over again and get as many points as I want. I can go up 1 over 1, up 1 and over 1, up 1 and over 1, and I can do that all day long. And I can get as many points as I want on that linear equation. Now, I can't do that particular action on a parabola because in a second degree equation that you see down here, there's no slope that continues. It changes all the time. So we're going to do something slightly different. But before we do that, I just want to point something else out. Here's my line that I get here. This is my line between all these. Let me see if I can get it to match up. There we go. Oh, no, not quite. Darn it. Oh, man. There it is. Okay. See if I can get it to match this time. Okay, close enough. There's my line that goes through these points, and this is my linear equation, and that's what it looks like. Notice that I could easily write this in slope-intercept form because I know that the slope is 1 and the y-intercept is at 0, 4, so that's 1x plus 4. That's something that we're going to be doing later with the parabolas as well. So anyway, something to keep in mind. Now, we're going to go through that same process for our parabola. In fact, I know that -3, 1 will zero out this parabola. I'll get 0 equals 0. It just so happens that this point is the vertex of my parabola, and that is a big deal. If you know where the vertex is and you know what the multiplication factor is, you can graph any parabola. This multiplication factor will either stretch your parabola taller or compress it shorter, and it'll be shorter and fatter or taller and leaner and skinnier if you like. And I'm going to go to -3, 1, -3, 1, which is in the exact same location. And the way I like to think of this is as a new origin. And I just basically think of this is my 0 point because I ended up with 0 equal to 0, didn't I? Get this straight. There we go. Still not quite on the line. Well, that's close enough. And there's my other one. Come on. So what I'm going to do is I'm going to treat this like a new axis. And I'm going to graph this equation. I should have used this one. Is the same as y equals x squared moved to here. And so I'm just going to graph y equals x squared as if my origin is right here. And all I have to do is take 1 squared is 1, 2 squared is 1, 2, 3, 4, 3 squared is 4, 5, 6, 7, 8, 9, and the negatives behave the same way. Negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9, and you get this nice standard shaped parabola. Now, the problem is a lot of times this number that you see right here is not 1. What if this number had been 2? In that particular case, everything else would be the same except for one thing. This parabola would be stretched in the y direction. And in fact, it would be exactly twice as tall because I'm going to be multiplying these numbers by 2. So here's what would happen. And I'm going to put this blue one. I'm going to put this one with the 2 in front in blue. So 0 times 2 is still 0. So my vertex is in exactly the same place. But notice that 1 squared is 1, but I'm multiplying it by 2. You see it's twice as tall as it was before. Now 2 squared is 4, but twice as tall is 8. And 3 squared is 9, and twice as tall is 18. I don't know if I can get to 18. 10, 11, 12, 13, 14, 15. I just made it to 18. And this side is going to do the same thing. This one's going to be here. This one is going to be here. And this one is going to be all the way up here. And notice that it looks very similar. Sorry, I can't draw it perfect, but I'm going to do the best I can. But it's taller and skinnier, isn't it? If the black one is a vase, the blue one is a tall, thin glass. Now, the same thing happens in reverse when I multiply it by a fraction. So look what happens when I multiply this by a fraction. This time, I'm going to do it in, let me get another color going. This time, I'm going to put it in purple. So I'm going to put it in purple, and I'm going to put a fraction this time. I'm going to make it 1/2. Now, a common mistake is to want to count up 1 and over 2 and up 1 and over 2. You can't count slopes with parabolas. What you can do, though, is you can compress them. And what I'm doing, if you can't see my hands, I'm actually going to squish this parabola down. And here's what happens. Instead of going to 3, 9, it's now half as tall, which is 4.5. So it's going to go to right there. So that point that's at 3, 9 is going to be half as high. And that point that was at 2, 4 is going to be at 2, 2. And that point that was at 1, 1 is now at 1, 1/2. And the 0 is still 0. And that point, let's see, I can't do another. I could do another one, I guess, but I could do the 16 and it would be down here at 8. Anyway, there it is on this side. And what you're going to notice is that my purple one is wider and been compressed. And I call this 1/2 the compression factor. That's all you need for all these kinds of equations where this number is positive. Now, if that number happens to be negative, you don't just get a negative slope, you actually, the entire parabola is negative. Because think about it. Let's make this red this time. And oops, I meant to erase it. Let's erase this real quick. Now, everything else is the same. Notice nothing's changed except one thing. We're going to put a 1, but it's going to be a negative 1 this time. So it's going to look just like that black one. The numbers are going to be the same, but instead of positives, we're going to get negatives. And so what's going to happen is we're going to get what we call, let me see if I can get my hand here, a reflection. It's going to reflect it down. And so it's going to go through 0. 0 is still 0. 1 is now going to go to negative 1. And 2 squared was 4, but now it's negative 4, isn't it? And so is this side. And the 3 was at 9, but now it's at negative 9. And what you get is the exact same shape that we had in black, but now it's in red. And there it is reflected down. And the fractions will behave the same way. We'll either get stretches or compressions. If it had said -2, then you could imagine that the blue one is reflected down. If it had said negative 1/2, then it would be the purple one flipped down. So there you have it. I'd like you to try one. Here you go. Here's your problem. And what I'd like you to do is find the special point and graph the parabola. So good luck. I will see you back again sometime. Bye.